Hello everyone. In this video I'd like to talk about acids, bases and neutralization reactions. Now it's really tailored for those studying the AQA syllabus, and this particular topic comes up in C2 part 2, but the principles basically apply to really any exam board. So we're going to talk about what makes an acid an acid, we'll talk about what makes a base in terms of the ion component, we'll talk about alkalis, and then what a neutralization reaction actually looks like, especially when we write one with a symbol equation. So let's start at the beginning. In fact, first of all, what I want to do is just write out a particular equation. HCl plus NaOH gives NaCl plus H2O. Now this is one equation that I give to my students and I say, just have a look at this and tell me what it is that you can see. What can you learn from just looking at this one equation? And you can pick up on points that we've got hydrogen here, chlorine here to make an HCl, which is an acid. You've got Na, which is sodium, and OH, which is a hydroxide, and that is sodium hydroxide, and that's a base. And we can see that we've got here the Na and the Cl together. Now together they collectively make sodium chloride, which is a salt. And then we've got at the end water. So we've got an acid and a base reacting to form a salt and water, and this is the key crux of a neutralization reaction. But one thing that is missing here is something called state symbols. So we're going to put those state symbols in. Now after HCl, technically I should have put the letters AQ. After NaOH I should have had the letters AQ. After NaCl also I should have had the letter AQ, and H2O should have had the letter L after. Now these are the state symbols. S is for solid, L for liquid, G for gas, and AQ is one that often many of my students haven't heard of before. This is aqueous. I'll just put the word here. And it means dissolved within water. Now let's think about what it is that makes an acid an acid. So we'll go through some of the key bits to do with acids. Now these are substances that contain hydrogen ions, or H plus ions. So that's the key thing that makes an acid an acid. It has H plus ions in it. If we think of hydrochloric acid, HCl, sulfuric acid, H2SO4. For example, all of the acids you can think of, ascorbic acid, nitric acid, they all have an H plus within them. Now the pH scale that you should have done lower down in school is a measure of the amount of H plus a solution actually contains. So the more H plus, the more acidic that chemical is, and the lower down on the pH scale it is. So a low pH means high H plus concentration and high acidity. Now, it's probably just worth noting that when you test for acids, there's a variety of indicators you can use. Universal indicator will turn a sort of reddish colour. You've got litmus that will turn red. You've got phenolphthalein that will go colourless. So it's important to just be aware of some of the indicators to identify these acids. Let's think about bases. Now, these are substances which can neutralise acids. That's how we define a base. It's a substance which will neutralise an acid. Now examples, if we just draw a little down here, put examples of bases include metal oxides and metal hydroxides. So if you just replace the word metal with any particular ones like sodium hydroxide, calcium oxide, magnesium oxide, calcium hydroxide, all these that I'm just coming out with, these are all examples of bases. Now a soluble base, one that can dissolve in a liquid like water, we refer to as an alkali. Now that's something key to just state there. So an alkali is quite simply a soluble base. Alkalis have a high pH, usually over 7 on the pH scale. Now let's think about soluble bases. So we said they're called alkalis, and what they do is they produce in solution OH minus ions. We call them hydroxide ions. they look a little bit like this. They're the OH minus. I'll just put it in brackets there just to identify it. So OH minus hydroxide ions in solution, what we get from these alkalis, these soluble bases. And it's those that really defines them. Now, we can see in this neutralization that we've got a salt. In this example, we've got sodium chloride. But in a neutralization reaction between an acid and a just random base, the hydrogen ions from the acid react with the hydroxide ions from the base to produce water. The other chemicals actually have little to do with the actual reaction itself. So if I just take the yellow, so for example, if we just put a little cross through this Na there and a little cross through the Cl, when we think of neutralization reactions and actual symbol equations, we don't really think about those. We actually represent them using the ions. So if we just draw a little area here that we're just going to make a note in. So when we look at neutralization reactions, we can say the H plus from the acid, that's aqueous, so in solution, plus our OH minus from our base, and once again that too is aqueous. That forms H2O, and that's a liquid. So H plus with an OH minus forms H2O. You can see H2 there and the O. And that's how you actually represent a neutralization reaction using these ions, using these and with state symbols. Now, we've said as well as water, when an acid is neutralized, a salt is formed. And the salt, you can guess the name just from well, where I've put the yellow X's, the other parts of the chemical that have been crossed out. So in this case, the sodium and the chloride go together to form a sodium chloride. A salt is formed when the H plus of the acid is replaced by a metal ion. So that's actually what's happening. The H plus comes off and we replace it with a metal ion. So in this case, the H came off and this sodium went to conjoin the Cl there. Now let's just think about exam questions you might get on this. So I'm just going to talk through one particular exam question and I'll tell you what the model answer would be. So if we just shrink the screen a little, put that there. So here's a particular exam question that I found. So some drain cleaners contain a mixture of sodium hydroxide and powdered aluminium. When the mixture is poured into a drain, it mixes with water and a chemical reaction takes place. Heat from the reaction helps to melt grease in the drain. Hydrogen gas is produced which stirs up the particles and helps unclog it. So the question might be, why do the solid sodium hydroxide and aluminium powder not react when stored in a sealed container? Now first of all, let's just put for this particular question, let's just show the chemical balance symbol equation that I'm referring to. So we've got 2Al, solid, we're reacting that with 2 NaOH. If you're unsure where the 2's come from, don't worry, if balancing equations is a bit tricky, I've got a video that specifically talks about that. 6H2O, that goes to 2 NaAl, OH4, and that's an aqueous, and 3H2. My writing's gone a little bit messy there, but there's a balanced symbol equation. So you've got 2 here, a 2 here, 6 there, a 2 there, and a 3 there. Now the question is, why do the solid sodium hydroxide and aluminium powder not react when stored in a sealed container? And the reason why they wouldn't react is because this here is solid. Remember, to be able to react, we need them aqueous. We need those ions, the H plus ions and the OH minus ions, in solution. So that's the answer. Because it's solid powder, they're not going to react. So that's a question related to this idea of having the H plus ions and OH minus ions in their aqueous form. So if we continue the question, the actual exam question says, sodium hydroxide is a strong alkali and would react with any acid in the drain. Name the ion produced when any alkali is dissolved in water. So for that one, any alkali, this is the particular ion we would produce, the OH minus. The second part to that particular question says, name the ion produced when any acid is dissolved in water. That would be our H plus. And the last and final part of that particular exam question says, name the compound formed when these ions react with each other. And that would be our H2O. And clearly we could have our state symbols next to these three. So what I've just read there is an example of a real exam question. Not too tricky. The key thing to remember is the H plus is the ion that makes an acid an acid. And in a base, it's the OH minus that's important. So soluble bases, particularly those called alkalis, produce OH minus hydroxide ions in solution. It's those two that react together to form water in a neutralization reaction. Okay, hope all that helps.